of course, I have f of x. And I'm going to say that this is what we are familiar with already, x plus a little bit. So this is a little bit. But right now it doesn't look like a little bit, right? Because I'm zooming in. And of course, this is f of x plus h. And here is our question. And you can say, this is very nice, but what are you trying to do? My first question is, and we're going to work on a problem in a minute. My first question is, part A, find the average rate of change. Between A and B. Between P and Q, I denoted them by P and Q. So P and Q then. And you will say, I already know what that is the difference quotient. You already taught us. The average rate of change is the same with it. So the average rate of change between P and Q. And you already know is f of x plus h minus f of x divided by h. In part B, I would like to ask, find the instantaneous rate of change or the slope of the tangent. So if I draw the secant line, I know that this is also the slope of the secant line PQ. It's the same thing. Difference quotient, the average rate of change of this function between P and Q, or the slope of the secant line PQ, they're all the same. They're all determined in the same way. But now, coming back to our graph, my next question that I didn't write yet, point B, I want us to determine the slope of the tangent line. So this is the tangent at P. So this is the tangent line at P to the graph of the function f at P. So my second question, part B, will be find the slope of the tangent line at P. So one more time, I don't want you to fall behind. So this was our graph of x. I picked 2 points, close or not close to each other. I used the general case. So P and Q, I determined the rate of change of the function f between P and Q, which we already know from last time. We are using what we already know. That is the difference quotient. We know the formula for the difference quotient, and we know that it will be identical with the slope of the secant line between P and Q, which we already determined. Is f of x plus h minus f of x over h. And of course I can have numbers here, and we will have numbers in the next example in a minute. But now I want to find the slope of the tangent line at P. How can I determine the slope of the tangent line at a point if I only have one point? I know in algebra this is not possible. I cannot find the tangent, I cannot find the slope of a line if I only have one point. I need 2 points to determine the slope of a line. So algebra doesn't work here. So how do I find the slope of the tangent line at P? I am going to think and talk about the following concept. Assume Q gets closer to P. Wait a minute. How can I make Q closer to P? Yeah, I'm going to make H smaller and smaller and smaller and smaller. And at some point in time, I will have this graph. I don't want to write it over there, so I'm going to have something like this. Here is the graph of f of x. Here is p. Here was q initially. Let's say now is here. This is my new q, q1. P doesn't move. So now the secant line is this. I will get a closer slope to the slope of the tangent. Initially, I had this slope, which was much further away from the slope of this line. But now if I bring q closer to p, now in position q1, this is the secant line and this is the slope. So obviously, this slope was far away from this slope. But now this slope is closer to this slope. Let's look at the next scenario. Still our function f, still point P, it did not change, but now I'm bringing Q to position Q2 right here. And look what happens. The secant line is this, and the tangent line is this. So would you agree that Q in position 2, Q2, and P are much closer than they were before, and now the slope of the secant line is way closer to the slope of the tangent line? Would you agree?
Yes.
So if Q gets closer to P, what really happens to H as I bring Q closer and closer and closer to P?
H gets closer to 0.
Very good.
H equals 0.
Never. Excellent. Thank you. Thank you for saying that. Q will never be the same with P. H will never be the same with 0. When we put this arrow, the arrow means approaches. Never equals. Never equals. So stay with me for one more second and then we can start working on a numerical example. So we said we cannot determine the slope of the tangent line at P because we only have one point of that line. But we determine the slope of the secant line, and now by making H smaller and smaller, smaller and smaller, smaller and smaller, and bringing Q as infinitely closer to P, Q gets closer to P, will never overlap P or be the same with P. That means that H will get closer and closer to 0, never equal to 0. And then the slope of the secant line PQ, please tell me what will approach. Not equal. This symbol says approaches. Will get closer and closer to what?
0.
Careful.
Oh, not 0. The tangent?
Exactly. The slope of the tangent at P, indeed. Thank you. That's the whole purpose. So as Q gets closer and closer to P, H gets closer and closer to 0, and the slope of the secant line will become, or I don't want to really say become, but it will be closer and closer to the slope of the tangent at P. Okay. I think that this leads us to our first numerical example. Okay. So as I said, I printed out the exercises at the end of section 2.1. and I would like us to work on an example. So I'm going to move this away. Any questions so far before we start our first numerical example? Do we understand the concept that we just discussed?
Yes.
Yes.
Is it difficult? Is it clear?
Yep.
Okay. So I selected problem 6 that we will work together as part of the quiz. So because of that, I would like to look at a similar example, like for example, problem 3. I don't know which page this is on. It's under exercises, problem 3, section 2.1. So 2.1, of course, problem 3. And I know you cannot see, but I will read everything to you. The point P, it's given to us as 2, -1. Lies on the curve, so we are given the function then, y equals 1 over 1 minus x. Maybe this is not a very good color, sorry. If q, of course, is q x comma 1 over 1 minus x, obviously, we just did that, 1 over 1 minus x. If q is this point, find the slope of the secant line PQ correct to 6 decimal places for the following values of x. So let's write them. I want to put them in the correct order in a table already. Don't put anything here just yet. So I am given from 1.5, 1.9, 1.99, 1999, 2.5, 2.1, blah, 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 but I don't like the way they are presented. They're not in the correct order. So I'm going to start with 1.5, continue with 1.9, correct order, ascending order, 1.99, 1.999. I will leave a blank space. Then I will continue with 2.001. The next in line will be 2.01. I don't have enough space in there. I don't want to squeeze it in. The next one is 2.1. And the last one is 2.5. So we are asked to find the slope of the secant line PQ. The slope of the secant line PQ for every x. Can everyone keep up? Are we okay?
So, can you move the screen up a little bit more? On
Like-
the paper, I mean.
Like this? This way or the other way?
Yeah, it's just like that, thank you.
Sure, thank you. Do not wait for me to ask if you have questions. Please unmute yourselves and say something. Anything. Are we okay?
Yep, we're all good, thank you.
Thank you. I don't want to repeat this operation 15 million times. I want to create the slope of the secant line. So I don't care for these numbers. Well, no, this is not a good page. I don't care for these numbers. I want it to give me a formula that creates or gives us the slope of the secant line PQ. What will you write? Because I don't even want to look at these numbers. I will cover it and then come back. So, page 11. Can anyone give us a formula for the secant line, the slope of the secant line PQ?
equals 1 over 1 minus x.
y2
y2
minus y1 over
x2
minus,
2 minus x1.
right. So y2 minus y1 minus over x2 minus x1, we know that. So now please give me so I can entry them correctly.
One over 1 minus x plus 1.
Excellent. Over
X minus 2.
excellent. This is what I'm going to put in my graphing calculator right this moment. Be very careful. Go to y equals, clear whatever you have from there. And let's enter this. If you forget parentheses around the denominator here, if you forget parentheses outside of the numerator, and if you forget parentheses around the denominator, you are not going to get the correct answer. Extremely important how we plug it in. Maybe the sophisticated calculators will understand. I don't trust any of them. So, but that's me. So 1 divided by, just make sure that it performs the correct calculations. You can do whatever you want. I will put parentheses. 1 minus x, close the parenthesis, and then I have plus 1, and close the parenthesis, and then I divide in parentheses by x minus 2. I have the formula for the slope. Because I refuse to perform this operation 10 times by hand. Can you? Yep. But why would you? Do we have this in the calculator? Like this? Or in any other format if your calculator is different?
Yes.
Good. And now with me, please plug in all these numbers in the correct order. So go to second and table. Make sure that you go first to second and table set, and make sure that you have the independent variable in the ask mode. Independent in ask, dependent of course always in auto.
How did you set it?
Second and table set. Second and table set.
And what are you setting it as again? I can't really see.
Ask and auto. The table start, it doesn't matter. I don't care for that. I would put in my own numbers anyway. Do we all have this yet? Is that a go?
Yep.
Good. So now second and table. Let's plug in the numbers. 1.5, enter. 1.9, enter. 1.99, enter. 1.999, enter. 2.001, enter. 2.01, enter. 2.1, enter. 2.5, enter. I'm ready for you to dictate the numbers for me, please. The first one, the first slope. Between what? Careful. What does the first number, which is 2, mean? What does it mean? It means the slope between the the slope of the secant line PQ when P is 2, comma, -1 and Q is 1.5, comma, 1 over 1 minus 1.5. The next one is when P is 2, comma, -1, but Q is 1.9, comma, 1 over 1 minus 1.9, and so on and so forth. So the first one is 2. What do we get for the second one? 6 decimal places they want. So you have to go back and highlight that number to get 6 decimal places because there is not enough room here. So go to 1.9, cross to the right, and highlight so you can see that number. So I have 1.111111. Can anyone give us the next one? Do we all get these numbers?
How many decimal places would you like us to
It
go?
says 6. The problem says 6.
Okay, thank you.
Thank you. One more time. Do we all get these or just me?
So in the first column, I'm not getting like a decimal place. I'm getting like 1 and 1, 2. And
Okay.
then in column Y1, I'm getting where the decimal places are.
Can you let me give you permission to share the screen. And can you have permission to share the screen? And if you want to show us.
It's on my calculator, so I don't know how. I don't even know if you guys will be able to see it.
Just share the screen, your screen first. Go to share screen. So I can see your function. So click on the green button to share screen.
I
But
did.
it's on the calculator.
It's on my cal.
Yeah, showing the screen wouldn't show what's on the calculator.
Oh, I'm sorry. Yeah, you don't have to share the screen. Just show me. Put the calculator to the. Yes. Okay. Closer. Let me see. Show me your function
How do I go to that?
in y equals. Just go to y equals and show me the function first.
Okay.
Oh, you just have to add some parentheses.
Yeah, I did it right. I probably missed one.
So you have parenthesis 1 divided by 1 minus x. That's correct. Plus 1 and go to the right. I want to see the last thing you wrote. Perfect. Put the cursor to the right so I can see you divided by x minus 1 minus what is it? X. We have x minus 2 and it is in parentheses. Very good. So now go back to press the second key
Okay.
and go where the window is
All right.
and make sure that the independent variable is in the ask mode. Can you show me that?
Okay. So I had it in the ask and nothing came up.
So let me see.
Okay, so I want to click it in the ask.
So
And I
the
wanna go
independent is in the ask mode, correct?
Yes, I want to put it in there now. And then
Okay.
I'm gonna do-
And now go back to second and table at the rightmost point, the rightmost button, and enter the numbers that I dictate to you. Enter 1.5.
Oh, okay. That's what I got it. I had to enter the number.
But you,
Oh,
otherwise, how will the calculator know, right?
I knew. I was.
So enter 1.9, enter 1.9,
Okay.
and after that you press enter all the time. And then 1.99 and 1.999.
Just pretty much put what we got answered.
All of them, yes, you have to put all of them.
Okay. I'll do it.
Thank you. Very good. Everyone else okay?